All right, let's talk about something we use every single second of our digital lives, but maybe don't think about too much networking. We're going to pull back the curtain on the invisible magic that connects your phone to, well, the entire world.
I mean, really, have you ever stopped to wonder? How does that song get from the internet to your earbuds wirelessly? How does a message you type get to the other side of the planet in less than a second? It feels like magic, for sure. But it's not. It's just networking. And we're going to break down exactly how it works. So, first things first, not all networks are the same size. Not even close. They come in all different flavors built for different jobs. Let's start with the absolute smallest and work our way up to the very biggest one there is. We'll start with what's right there with you, your personal area network, or PAN. This is basically your own little personal tech bubble. You know, when your phone connects to your smartwatch or your wireless headphones. Yep, you just created a PAN. It's small, it's simple, and it's all about connecting your personal devices. Okay, now let's zoom out just a little bit to your house or your office. That's a local area network, or LAN. Your home Wi-Fi is the perfect example. It's the network that connects your computer, your game console, your TV, all together under one roof so they can share an internet connection. So what happens when you need to connect a bunch of LANs together across, say, a whole city? Well, then you've got yourself a metropolitan area network, or MAN. Think of a big university campus with dozens of buildings, or a hospital system with locations all over town. They use a MAN to link all their separate networks together. And finally, the big one, the Wide Area Network, or WAN. This is the network that connects everything else, cities, countries, even continents. And the biggest, most famous WAN of all? You're using it right now. It's the internet, a truly global network of networks. Okay, so we have these networks of all different sizes, but how do the devices on them actually talk to each other? What does that conversation look like? Well, it turns out there are two main ways they do it. The one you use most often, by a long shot, is the client-server model. It's pretty straightforward. Your device, like your web browser, is the client. It asks for something. When you search on Google, your browser sends a request to one of Google's massive, powerful servers. That server finds what you need and serves it back to you. You can think of it like a little dance. 1, the client asks for something. 2, the server listens and finds it. 3, the server sends it back. That's it. This is how most of the internet works. It's organized, it's secure, and it's how you do everything from online banking to streaming movies. But what if you just got rid of that big central server? That's the whole idea behind peer-to-peer networking, or P2P. In this world, every single device is both a client and a server. They're all peers. They talk directly to each other to share things with no company or middleman in between. So you see, there's a really important trade-off here. The client-server model gives you that central control, which is great for security. But in a peer-to-peer network, because there's no central server, there's no single point of failure. If one peer goes down, the network keeps on chugging. The work is spread out across everyone. All right, so to make any of this stuff happen in the real world, you need some hardware. And this is where a lot of people get confused. You've got these little boxes with blinking lights, but what do they actually do? Let's clear up the difference between a modem, a router, and a switch. First up, the modem. Its job is simple, but it is absolutely essential. It's your gateway to the internet. It takes the signal from the cable or phone line coming into your house and translates it into a digital signal that your computer can actually understand. Plain and simple. No modem, no internet. Next up, the router. So the modem brings the internet into your home, right? The router then takes that one connection and creates your own private network, your LAN. It acts like a traffic cop, directing that internet connection out to all your different devices, your phone, your laptop, your TV, usually over Wi-Fi. And finally, we have the switch. Now, a switch is kind of like a power strip for your wired internet connections. It lets you plug in a bunch of devices using Ethernet cables. But here's the cool part. A switch is smart. It knows exactly which computer asked for what piece of data, and it sends it only to that computer. Older gear used to just shout the data to everyone, which really slowed things down. Switches make things way faster and more efficient. Okay, so we've covered the different sizes of networks, how devices talk, and the hardware that connects them. But now we're going to get into the invisible rules of the road, the stuff that determines how fast and reliable your connection actually is. When we talk about internet speed, we have to start with something called bandwidth. And honestly, the best way to get it is to think of it like the width of a highway.
A bigger, wider highway can handle way more cars at the same time, right? While higher bandwidth can handle way more data at the same time. It's the maximum capacity of your connection. But bandwidth isn't the whole story. Latency is the delay, how long it takes data to get from here to there and back again. Think of it as your travel time. Ping is just the test we use to measure that latency. And finally, throughput is how much data actually gets through successfully. You could have a wide road, but if there's a traffic jam, your throughput, the actual cars getting through, is going to be low. Now, how are all these devices and wires and connections actually laid out? Well, that layout is called a network's topology. Don't let the fancy word fool you, it's just the map of how everything is hooked up. And there are a few common ways to do it. The star topology is what you probably have at home. Everything connects to a central point, like your Wi-Fi router. The bus topology is pretty outdated. It's where everything shares one single cable, and if that cable breaks, whoops, the whole network is down. And then there's mesh, where every device can talk to multiple other devices. This creates a ton of backup routes, making it super reliable. So as we wrap things up here, just remember this. Every single thing you do online, every message you send, every video you watch, including this one, it all travels through this system. From the tiny pan in your pocket to the global WAN, using these rules and this hardware, it all works on these exact same principles. And that really brings us to the most important point. In today's world, knowing the basics of how this all works isn't just for IT geeks anymore. It's becoming a fundamental part of digital literacy for everyone. And why is it so important? Because this stuff, it's the foundation. It's the bedrock that all the other massive technologies shaping our world are built on top of. You can't really understand cybersecurity or cloud computing or even AI without first getting a handle on networking. Learning how these networks are built, how they talk, and the rules they follow, it really empowers you. It helps you make sense of the digital world we all live in. And what you've learned here, this is just the start. This is only the beginning.